Okay, so welcome back, and we're going to do the proof of part one in the theorem in the previous video. Okay, so that involves the sum. We're only going to do the sum because the difference is done very similar. So we're going to do the sum of two power series. Okay, so again we start with the assumption, right? Suppose that we have two power series, c sub n times x to the nth power. So we have that series, and we have the power series n equals 0 to infinity of d sub n times x to the nth power. And let's assume that these converge to the functions f and g respectively on the interval I. And also, furthermore, so we're going to start the function by saying, okay, let x, okay, be in the interval I. So I'm going to use a different symbolism. So let x be an element in I. So this is a symbol for being an element in. So let x be an element in I, and let what do we want to use? Let s sub n of x and t sub n of x be the partial sums, right? Let's let those denote the partial sum, the nth partial sums of the series. Okay, so let these denote the nth partial sums of the series. So of okay. Respectively. Okay, and of course these go from 0 to infinity. N equals 0 to infinity. Okay. Now, okay, good. So now that we have that, now we can use convergence of sequences. Okay, so based on this, we know that the sequence of, the sequence of, come on. Converges to f of x and the sequence of t sub capital N of x. So the sequence of partial sums converges to f of x and g of x respectively. Okay. And then furthermore, the nth partial sum of the sum, right? So if we take, so furthermore, of these two, so it's going to be Cn plus. Okay, so we know, okay, so furthermore, the nth partial sum of that series, the series of the sum of the two powers, power series, is what? Okay, so how would we represent this? Well, we represent this as an nth partial sum. So we know that the nth partial sum of this is going to look like what? Well, let's go back up here. And so the nth partial sum of this is going to be what? It's going to be n equals 0 to n. Did I? Oh, hold on a second. This should not be to infinity. That should be to capital N. Sorry about that. Oh, no, never mind. I had it right. I'm going back and rethinking things. Okay, nope. I was just denoting them. Okay. Never mind, I was right the first time. Okay, so now we can represent the nth partial sum of this just as this. And this is going to be C of n x sub n plus d sub n of 2 times x sub n. Okay? Now, by properties of series, convergent series, right, we can split this up. And this is equal to n equals 0 to n of c sub n x sub n plus n equals 0 to n of d sub n times x to the nth power. Now, well, what is this equal to? Well, this is just the nth partial sum of each of the individual series. So we can change this to what? S S sub n of x plus t sub n of x. Now, okay, now here's the thing. We know that these are these denote two convergent series, right? That's what we're assuming. We're assuming, so this represents the partial sequence of a convergent series. This represents the partial, let me rephrase that. This represents the partial sum of a convergent series. This represents a partial sum of a convergent series. And so because, based on that, because the limit as n approaches infinity of the partial sequence, or excuse me, of the sequence of partial sums, as n approaches infinity, right? So if we take this, okay, so because this is equal to this, because again, properties of limits, right? Since these are, again, convergent partial sums, right? So as the n approaches infinity, these partial sums we can say, well, this is going to be the same as the limit as n approaches infinity of s sub n of x plus the limit as n approaches infinity of t sub n of x. Okay, which obviously is equal to, well, this converges to f of x, and this converges to g of x. Now, what do we get from that? Well, because that is true, what does that tell us? Well, that tells us that the sequence of partial sums converges, right? Tells us that the sequence of partial sums, which is this, converges to what? F of x plus g of x. So therefore, oops. So, because the sum of partial sums here, so this is the nth partial sum, is represented by this, and we know that this is equal to this, which is then is equal to this, and because the limit of the sum of these two convergent partial sums is also equal to the limit of these separated, which is equal to this, which tells us that the sequence of partial sums for this converges to this, which means that therefore the infinite series of this converges to this. And we're done. Have a great day.